electromagnetic devices and related circuits, magnetics and magnetism. At the end of this session, students should be able to draw the magnetic field patterns for the bar and the horseshoes of magnets, state the law of magnetism attraction and repulsion, describe the magnetic lines of the poles and list their characteristics, define the magnetic flux density, and solve the calculation involving these quantities. Explain the magnetic induction and its effects, describe the principles of the magnetic spinning and its applications, list the practical applications for the permanence of magnets. What is magnet? This is for the magnet bar and the horseshoe magnet with the iron filling. A solid substance which has the property of the attracting of the is a solid substance, which are called the magnetic substance. So in this case, there are two magnets. So that the point you place a magnet near the iron, so that the magnet attract the iron with you. So the type of the magnets can be the temporary magnet. So temporary magnet can be easily magnetized, and it loses magnetism when the magnetizing force is remote. Example, salt iron is a temporary magnet. Permanent magnets are easily magnetized, but it retains the magnetism when the magnetizing force is remote. For example, the hot iron. A measure of how easily the material can be magnetized is a permeability. The permeability is mu. This is the measurement how easily a material can be magnetized. So magnetic materials are the ferromagnetic. They are the high permeability. Usually the ferrous materials. They can be the iron, steel, nickel, cobalt, aluminium, and the rare earth. Those are the ferromagnetic materials. And ferrites are the ceramic with the metal properties. Aluminium is a alloy of the aluminium, nickel, and cobalt, and copper. Rare earths are the group of chemically similar metallic elements with the atom number 57 through to 71. So atomic number is 57 to 71. Those metals are the rare earth metal. They are the group of chemically similar metallic elements. Non-magnetics are the permeability of the ones. In this case, usually the non-magnetic. They are the air, plastic, wood, water, paper, and clothes. They are non-magnetic material. Permeability is 1. So the magnetic materials are the paramagnetic materials. Some non-ferrous materials are the paramagnetic. They are the aluminum, platinum, manganese, and the chromium. The permeabilities are slightly higher than the 1 because the weakly are magnetized in the sun direction as the magnetizing force. Diamagnetic materials are the other non-ferrous materials. They are the gold, silver, copper, and zinc. Permeabilities are less than the 1 because they are weakly magnetized in the opposite directions to the magnetizing force. The compass is an example of the magnet. The end of the magnet which points the north is called the north-seeking pole. This is often shorter than north pole. So this is what the compass. So in this case, we place two magnets. So this is what the north and south pole will be attracting. So this is magnetic lines are coming from here to end to the here. So this is we place two magnetic poles. In this case, south and north are connected. So place are adjacent. So they are magnetic fields between the north pole and south pole. Also that they are original magnetic fields are running. So this is the unlike materials are attract. This is unlike because of the north pole and south pole are attract. Unlike poles are attract. Unlike poles are attract. And like pole, north and north pole will be repulsion because of that the fields will be like this. Like poles are repel. Okay. Like poles are repel. And this is for the north pole and north poles will be repelling. Magnetic line of poles are here. You can see the magnet north pole and south pole. So the line of poles will be flowing from the coming out from the north pole and the end at the south pole. So the insides are the magnetic flux are flowing from the south to north, but the outside it flows from the north to south. This is called the flux. So this is the arrow directions are the magnetic flux. Magnetic line of poles are properties. These kind of properties are the completely closed curve. Have a definite direction, external from the north to south, internal from the south to north. Never cross. And perfectly elastic. And paths are affected through the non-magnetic materials. So this is the properties of the magnetic line of poles are properties. Magnetic fields are you can see that here tools are not as solvable. On here you can put iron, so iron the particles waves are moving like this. This is called a power magnet. So we put there are two magnets like this. The magnetic lines of force are we flowing here. This is the direction of magnetic line of force. Unlike force are attract. And like force will be repelled. Magnetic fields are demonstrations. This is power magnet. Residual magnetism is how much of magnetism are retained when the magnetizing force is removed. Returnability is a measure of the material ability to retain the magnetic field. The higher returnability means the higher the residual magnetism. Reluctance is the opposition to the magnetizing force. Magnetizing flow is a flowing is opposed by the characteristic. This is we call the reluctance. The SI unit of magnetic flux is a Weber. 1 Weber equal to 10 power 8 magnetic line of force. Magnetic flux per unit area is called the flux density. And the SI unit of flux density, the Tesla, Weber per meter square is 1 Tesla. So in this case, B equal to 5 by 8. B is the flux density, 5 is the flux in Weber, A is the area in meter square. We have to calculate the equation. So phi equal to 2 into 10 power minus 4 Weber. A1 is 100 millimeter square. We have to calculate the flux density B. Also the A2 is 400 millimeter square. We need to calculate flux density B. B equal to 2 into 10 power minus 4 divided by 100 into 10 power minus 6. You got a 2 Tesla. Similarly, say 400 millimeter 2 into 10 power minus 4 divided by the 400 into 10 power minus 6 to 55 Tesla. And another thing that we have to calculate the phi equal to 18 micro Weber. A equal to the A1 equal to 900 millimeter square, flux density have to calculate. In this case, 18 into 10 power minus 6, divided 900 into 10 power minus 6, you got the 20 milliliter. So the air gas is 1 by 7 Tesla, and air gas flux density is 1 by 7 Tesla, and air gas area is 300 millimeter square, and pore area is 200 millimeter square. We have to calculate the flux in air gap and the flux density of the pore. So in this case, our flux in air gap can be calculated B into A. So the 1 by 7 is a B. Area is 300 millimeter square. So we calculate 300 into 10 power minus 6. You got 510 microwave. Flux density of pore is 5 by 8. So 510 divided by 220 into 10 power minus 6. You got 2.318 Tesla. Magnetic key bars are the soft iron bars attached to the pole plate help to retain the magnetic strength or the permanent magnets. Magnetic screenings we use the provision of bars for the low reluctance to protect the operator from unwanted or the undesirable magnetic influence. So this is for the magnetic screening. We have to provide a magnetic screening. If you do not want the magnetic field affected your equipment, you have to provide this magnetic screening. This is the provision of the path for the low reluctance to protect the apparatus from the unwanted or undesirable magnetic influence. We applicate, so this is what we use a magnetism in the generator, and also we use a microphone and a speaker. And this is what also we use a magnetism in radio television. Also we use a mesh guitar and measuring instrument. This is an application of magnetism. The next program, lesson 2. We are also talking about the electromagnetism. So that we talk about the electromagnetism. At the end of this session, students should be able to draw the magnetic field patterns around is a current carrying conductor and a solenoid, state and apply the right-hand rules for the conductors and the solenoids, draw the field patterns around two adjacent current carrying conductors, describe the forces between the two adjacent current carrying conductors, list the factors that determine the field strength of an electromagnet, define the turns electromotive force and calculate its value, list the practical applications for electromagnets. The electromagnetic field is also this one here. So this will be the when there is an electrical current flow into wire. So that this is the flux happening around the magnetic field around the current carrying conductors. This is the electromagnetic field. So that we how the fields are connection. Thumb positions are thumb points the direction of current, finger point the direction of flux. So in this case, you can see there's a symbol. So the current flowing away. This is the cross. Current coming to us. So this is the top. So that in the conductor current flowing here. In this case, this side is a symbol A for the current flowing away. Symbol B is the current coming to us. So this means the symbol B means the current is moving out of the place. symbols are cross BA mean the current moving into the phase. When the two currents are flowing, so you can also see there's a magnetic flux here like this. So this is for the current flowing away, so that will magnetic flux like this. Here current flowing to what? Magnetic field around like this. So these two currents are these two are current called the same direction of current. Those two fields they are attracting, they are opposite. So when the current flowing like this, so they are the direction here, the direction different. So in this case, they will be repelling. So this means the same direction, current it will attract, opposite direction it will repel like this. So this is we have to do this magnetic field that we current getting flow. In this case, the thumb direction indicate the current direction, so the finger direction indicate the magnetic field around it. So also the magnetic field around is you also see the if you connect the current flow into the finger direction, magnetic field direction, the thumb direction. So this is the right hand rule. You hold the coil by right hand, and then the current flow into the electric current flow is your finger's direction. In this case, the magnetic field is indicated by your thumb direction. So this is for the two magnetic field, two wires. All the wires are quite we connect like this, so the magnetic fields are happen like this, around like this. So in this case, the direction of the field is south to north. So that will be the in the south coin. They are the direction of the magnetic field. So if you wind the wire on this coil, the electric current I flow in the direction. In this case, it happens the magnetic field. So normally this is iron bar electric current flow. Because of this current, it can produce the magnetic field. So in this case, not both and solve happen. In this case, the magnetic flux can be calculated. Magnetizing force Fn is equal to I multiplied by N. I is a current, N is a number of turns. Or the flux can also be calculated In divided by Rm. In this case, I is a current, N is a number of turns, Rm is a reductant. Applications we use the electromagnetic effect. Credit, it attracts the armature to the pole phase, the magnetism attached to the armature. So you guys use the operating coil, this is a flux path, this is the air gap, and conductor. So relay conductors, buzzer base, we use that magnetics. Application we use as solenoid. Solenoid attracts a sliding plunger into the coil, so we use the bar, relay, brake, and the conductor and the door chain. We use a different magnetism. We need the magnetism to attract the magnetic materials to the both phase. We use the glass Kyaw separator lithium magnet. Then you have to do the practical exercise. So we talk about the magnetism and electromagnetism, lesson 1 and 2, I explain about. Okay, then this is for your lesson. After this, you also have to do this trade 2. Okay, we talk about the advanced diploma electrical trade. So the electrical trade 2022.htm you enter. The website equal to the IQI.college.com/electrical trade 2022. Then you have to do is you have to read the G106. Click here, you can read the G106. G106 this is a workbook. You study the workbook. Also the answers are also provided. So that workbook you have to read through the workbook and the exercise. I have already given you some lesson about the G106. This is for also this is for the answer. So those answers are included in the workbook. This is the answer for the workbooks are question included in the workbook and also the answer. So this answer also you have to read to do the exercise and answers. In the meantime, also you have to view the video for the G106. This is the way you have to do the electrical trade. Now this is an advanced diploma electrical engineering. The diploma lesson that you also have to do. So you go down this one and then you see the electrical diploma 2022. Go down here. See the electrical diploma 2022.htm. Click the Disney, and then you can see the after that you can see there's a video lesson. Go down here, so study option 3. So YouTube video for the electrical engineering lesson. Click this one, and then you also click the lesson. And then what you have to do is you have to do there's a machine, AC machine.